So I shall get mu 0 b log d plus a upon d whole multiplied by I and then divided by 2. So I can write down this equation as phi equals to mu 0 b upon 2 log d plus a upon d into I. And dear students, then you will find that comparing this equation with the standard equation phi equals to mi, I get the coefficient of mutual induction. The coefficient of mutual induction is m equals to mu 0 b upon 2 log d plus a upon d. For this system in which there is a current carrying conductor and a loop of rectangular shape is placed nearby. I hope you can understand it. Apart from it, today I will tell you one more interesting aspect of mutual and self-induction. I am showing you few circuits, one which was used in the Faraday's second experiment. I will ask you a question also. This is one arrangement. This is the second arrangement. This is first arrangement, second arrangement. Let us look for some other type of arrangement also. Third type of course we are changing the current in this primary circuit. And the fourth arrangement is, dear student, like this. This is fourth arrangement. Now you can see in all these arrangements there are the two circuits which were used in the Faraday's second experiment to demonstrate the mutual induction phenomena. Here the two circuits are coaxial and placed close to each other. Here they are placed close to each other but they are not coaxial, mean axis of this circuit does not coincide with the axis of this circuit. And in this case number 3, the two circuits are not only coaxial but they are winded on each other. When both the circuits are winded on the same core. And look at this. The two circuits are neither coaxial nor they are close to each other. They have been separated by a large distance in comparison to their dimensions of ohm. Now you can ask that if I repeat the Faraday's second experiment, that is, I start changing the current by same rate in all the four circuits, then you will find that the value of induced EMF is different in all the four circuits. if I ask you where it will be maximum, most of you can easily answer that in the circuit number 3, the induced EMF will be maximum. Then it will be in circuit number 1st, then in 2nd, and then in 4th. Because the reason you have to understand, whatever change of flux is taking place in the case number 3, all the flux lines will be associated with the secondary circuit. Here few of the lines will be escaping, like this line is not passing through, these lines are not passing through the secondary circuit. Here, but in this case, whatever magnetic field lines are produced, they will be passing through the secondary circuit also. Here the chances are few. So definitely few lines can pass through, but here the chances are very less. Hardly any field line of the primary circuit will be passing through the secondary one. So induced EMF will be least here and maximum in this case. Here I can say that every circuit has its own self-induction, and then there is a mutual induction. So obviously you can have a question in your mind that what is the relation between this coefficient of mutual induction and coefficients of their self-induction. Normally a question arises in the mind of all students at first year level. I would like to answer it, that if there are two circuits of coefficient of self-induction L1 and L2 respectively, and the coefficient of mutual induction between them, then M is directly proportional to square root of L1 L2, or M is equal to some constant K under root L1 L2. This K is called coupling constant, and it is the maximum value of K can be 1, say almost in this case K is 1, when the flux associated with primary circuit is completely connected with the secondary circuit. And here K is very small. I will never say it is 0, but it is very small. And here K has good value close to some 0.5, 0.6. K depends upon, obviously K depends upon orientation, number 1. Orientation of the two circuits. It means depends upon the flux, magnetic flux linkage. Magnetic flux linkage. This formula can be proved easily using two solenoids, and I will consider the complete flux linkage between them. That I will tell you. You can prove this formula using two solenoids identical to each other. You will find that it is very simple for us to prove that particular formula. I will tell you in the next lecture. So here there is a relation between coefficient of mutual induction and coefficient of self-inductions of two independent circuits. Thank you.